Oh, I'm live. I'm live. Okay. Hello, everybody. Okay. Hopefully, hello. Hopefully, YouTube is people joining in here, there, everywhere, I hope. Okay. Now, largely today, the idea is, and I apologize for any confusion over this. Hopefully, everyone kind of got the quick news flash that the project is actually due the end of the day tomorrow. So when in doubt, it's Wednesday night that the project is due. So the next one will also be a Wednesday night, whenever that is. And the idea for today's class is studio for the most part. So this is like, I don't want to get barraged. If you have questions regarding the project, now is when to ask them, not at 9 o'clock tonight, or I mean, somewhat tomorrow. I've got other classes I'll be teaching, like, certainly tomorrow afternoon and into the evenings. It's kind of my late class, so I want to make sure that people have their pressing questions answered today in class. So normally, like the class before the project is due, we want to say, okay, we're dedicating that to any unanswered issues and so on. Let me go ahead and let's see. So this is going to be work question time right now. Yes, that is the main idea, that this would be work question. I do have stuff. I always have stuff we can certainly talk about and extend beyond that. So if I want to see sort of how this goes in terms of people asking questions, if there are enough specific things that people want to talk about group-wise before I dive into just turning off my video and all that and so on. But it does look like, let's see, live meeting-wise, there's only 6 people watching on Discord at the moment. And I don't know exactly how many. 15 people over on YouTube right now. So I guess I'll assume most everybody's over on YouTube. So, and boy, I spelled Apple wrong there. Let me fix that, because that'll just drive me crazy. There we go. That was just terrifying. Altogether terrifying. So the Apple Tree program, the Apple Tree project. So I'm just going to, what I'm going to do is I'm going to open up my version of the Apple Tree, the Simple Tree program. I'm going to run through that just as an example. And this way, I'm going to kind of show all of the requirements in there as they're being used. If you have, in case you haven't noticed, on my channel there is also lots and lots of other versions of the class and project as well. So if you're ever like, you watch one of the videos and you're still kind of like scratching your head and you haven't quite figured it out, or there's any kind of issue, you can do a search of my YouTube channel, and often you'll find other versions of the project there. But for now, let's do this. I'm going to use the Simple Tree. The last time I did an extensive one on the what is it? The Scarecrow version of the game, which is funny because I should have done Scarecrow for Halloween as opposed to Scarecrow for the summer class, and then the Apple Tree for the other class. Oh, well, you get what you get. So in this case, I'm going to show the Simple Tree one just because it's kind of simple, right? Simple is good. So let's look at the Simple Tree again. Of course, this is done in Unity 2019 as opposed to 2020, which is what you're going to have. So your version will, of course, be better. Well, dark mode or something like that. But I want to go through the basic things. Now, hopefully you should have a starting scene, which is probably not like this. It may just very well be the scene where you're like, okay, I'm joining, I have 4 buttons. I have the adventure game, the apple tree game, the shmup game, which we haven't talked about yet. And then there's the platformer or final project game. All right. So there's going to be some sort of initial screen, and you're going to go from there to your game. And then when your game quits and so on, if you want to have a hooray after you're done game, that's fine as well. But you want to be using your existing project as well. Hopefully you should not have had to share a new project with me. Still, there's 2 people I have to reach out to. You guys, I'm sure, know who you are, that I've just been kind of swamped with other things and double checking on there. And Unity's been a little bit weird lately, but hopefully everybody else, as long as you're using the same project, remember, upload things. Don't wait till the last minute. You shouldn't only be using Unity to submit your projects. You should be actually uploading as you go along the way. Right. So that's good and important to do. So in my case, even I'm going to go ahead and for some reason, the version on my hard disk here is slightly newer than the collaborative version. Because I created that Subscene. And maybe this will be a cool thing to show you guys as well. Why not? So I'm going to publish this. It's transferring this. So anytime I really make a change that I want to save, I should put that there, right? It should not be, this is not a submission process. And so you can say to yourself tomorrow night, like, oh, okay, I already put everything up, as long as you actually did. But always just do that anytime. It's your backup. It's your backup of your game. All right. Now, what was that about, that Subscene thing? Well, first off, let's look at the game here. Let me keep an eye. Is an early way to submit the project. Oh, I will put the submission, the LMS submission, up right after this class. Okay, we'll do that. So you do that. And remember, you can always submit early and often to the Unity collab server as well. All right, so that should be, don't wait till the last minute to do that. But LMS, I'll put up at the end of class today, if depending on where we leave things and where my dinner winds up and so on. Okay, so here's the game. Now, I hit play. The main game starts. The score to beat is 28. It's telling me. There is music. I actually put a volume slider on my music. That's optional. Volume slider is sort of optional. Displaying the high score on here. That's a good, cool thing, right? I could just call, you remember get player prefs? You could do that. That's probably what happened on this one. Get player prefs would show me what that score is. I have a quit button that would quit the game, which is good if this was a standalone game. I wouldn't want this to be like infinite, so start thinking game design in general, right? This is my menu screen here. So I could quit back to the main game. And then I also have the start button here. So click start it up. All right. Now, you might have noticed when I went there, let's see, I'm going to do that again. I'm going to hit play. And this is the bonus weird thing. See all those apples that all came into existence immediately? Right? You notice I hit start and there's a whole bunch of apples on the screen at once. Weird, right? That's not a normal feature. But that's something I demonstrated for our Game Dev 1 class. And I'm going to go ahead and I'm going to mention it to you now, too, because it's a bonus. All right. We'll see here. There's gameplay. There's starting scene. Now, starting scene was this one. Gameplay was this one, which has this extra paused thing showing up here. And then there's this thing called Subscene. Now, Subscene currently has no cameras rendering. And if I look at Subscene, you can see this. Here's the scene itself. It has basically 7 prefabbed apples in. And for now, just so you could see this, I'm going to say, let's put a camera in the scene just to make life a little bit simpler. And I can double click on the camera. I don't see anything there. I'm going to put the camera, change its position to -10. Maybe I can see things. I'm going to point it at 0. All right. So I've pointed the camera to the normal place the camera points. And you'll see there are 1, 2, 3, 4, 5, 6, 7 apples here in this scene. And normally there isn't even a camera, right? There's just 7 apples. So after I put those apples in the scene, and maybe I'll just, for the heck of it, I'm going to go into my hierarchy here, and I'll move these around. I'll use my little mover, move them around. I'll start them all up higher, and maybe these over here. I'll move them up higher, and just for the sake of making it interesting, I'm also going to go to their not their transform Apple script. Let's go look at their. I'm going to look at their shaders here. Audio source, audio script. Colliders. All right, I'm not going to change anything other than that. So I've got these 7 apples, and I'm going to get rid of again this camera in this scene. So I'm going to delete the camera. Now the thing that I'm doing here, and you don't have to do this for your game, but it's something to keep in mind. Now, you may at some point say to yourself, well, how do I do, for example, if I have a game that has multiple levels in it? We did that with scenes, but what if I have a really complicated game that I want to dynamically load, or I have lots of different rooms, or there's a really crazy complex world that the user can seamlessly navigate around in, right? And I want to add things into the scene. I want to add additional rooms or add additional things into the scene, right? You can add scenes to other scenes, right? So this starting scene here, our normal scene, I'll say save now, go to gameplay. This is our normal scene. And the cool thing in that scene, I think I did it in the manager, game manager. Is that where I did it? Hopefully. Or maybe I didn't even do it in the scene. There is the possibility for you to, in a scene, you'll see this is the start method for this game manager, which is in my main scene there. And you'll see it goes through, does all the normal stuff that you probably are doing, like getting your high score preferences and showing scores and doing all that stuff. But there's this additional line where it says scene manager.load scene subscene load scene mode additive. Okay. And normally when you're loading scenes, you are not using this load scene additive. This allows me to actually load a scene while another scene is running. So say I saw that, the players getting close to the castle. So I need to load everything that's in the castle. I could have created the castle as a separate scene and then loaded it as the player got closer to it, right? That's an option. You can do things like that. You can do it asynchronously, so it's not going to just stop and wait as well. So do it sort of dynamically. But this is what this is doing here. It says this fantastic, something to think about as you get more and more advanced. You really don't need to use that in these projects, but it's something worth knowing about, especially as you start doing more complex projects. And the other thing that I do is I set this flag here, subloaded equals true, so that I also am allowed, if I hit the pause key, pause play, I also got rid of the apples. I unloaded the scene that was there. So you'll see in my game, if I press play, and I'm going to try to pause real quick, I hit pause, all those dropping apples, that scene got unloaded, right? And you can even see, ready, watch this. Start. Okay, I paused the game. And over here in my hierarchy, you see gameplay and you see subscene, right? So it's loaded this scene on top of this other scene. So it's sort of like having a, mega prefab that it can contain prefabs and objects and things and whatever, all in their own scene. So I could even have like the player as its own scene that could be loaded into another scene, things like that. So it's another level of hierarchy you can actually take advantage of. All right, so other things that may be very helpful. Okay, we're gonna sidetrack here. So as you are working on your project, you may encounter bugs in your code. You may have bugs in your code, or you may want to know, okay, is this code getting called? And we've done one debugging technique, which is just a good old print debugging, printf, print logging, and so on. Debugging. We can just print things to the console to see what's happening if we have an issue. But maybe we want to do something more sophisticated. We don't know exactly where a bug is. We don't know exactly what the issues are. And instead, we want to kind of step through the code and kind of look through the code as it's executing. Okay, so we're going to use the built-in Visual Studio debugger to do this. All right. So imagine I had some kind of weird thing and I wasn't sure why aren't my player preferences showing up? So I want to step through this code, and I don't want to put a million print statements in here to see what's going on. Instead, I want to set a breakpoint, right? So if I wasn't sure, why is something not working correctly in my start routine? I'm going to go ahead and put a breakpoint on one of the early lines of code, and I just go ahead and I left click there, sorry. All right. And then I can say attach to Unity. All right. And you'll see now it's attached to Unity, kind of ready to go here, right? And the moment I go over to Unity and I press play, you'll see this little yellow arrow pops up and it brings me back to my code over here. So now it's paused me. It's paused the game, paused execution at that very line that I've set that breakpoint at. And I could even look here and say, well, okay, what's going on, right? Paused text equals null, right? It hasn't set that yet. So let's do this. Let's execute that line of code. I can come up here. Yours may be set up a little bit differently. You might have to say, go to under there's some arrangements and things, which tools get shown and so on. So normally these things also show up under the debug menu, for example. So if I wanted to, step into code, step over code, and so on, I'm going to do this from this over here, this interface here. So I'm going to say, all right, I want to step over. I don't want to go actually into GameObject.find. I just want to step over that line. So I step over. That means that line was now executed. And you'll see paused text down here has changed. Now, paused text is pointing to a valid Unity game object, Unity Engine game object over here. So I can see what it's pointing to, right? It's pointing to the ptext game object. And I can see all of its values, what layer it's on, is it static, and so on and so on. All the things about it. I can see the transform for it, where it's located, et cetera, et cetera, et cetera. Right. I can also see that this here, this little structure, is this component that I'm working on right now, the game manager. And I can see its own variables and structures and everything that are within there. So I can kind of see, okay, well, up here, high score is set to 100. So if I'm looking here, where's high score? Oh, okay, there, that's set. And it probably was set, where did that get set? Oh, there it is, high score is already set. I'm about to see high score, current score. These are the things. It tries to anticipate and say, okay, here's what I'm about to change. So that's, and I can go ahead, step through my code, step. Okay, now it has set that pause text to active, or set it to inactive. So I can't see the pause text. Ah, okay, the pause text is this part right here, right? So by setting that to be inactive, once we start rendering the screen again, that's going to disappear. So that's what this paused text set active is going to do, right? And high score is going to be set. It's going to go ahead and grab my player preferences. My high score was 100, but let's see. Now it's going to set it to, let's see, high score is now 28 because this succeeded. This function happened, right? And then I could go through and even say, okay, load the next scene, set subloaded to true, and so on. All right, now it's going to keep going through and update is going to be called. But I'm going to go ahead and I'm going to press continue, which means just keep playing from there. So I hit continue, and the game then continues on. Now, if it encountered that same breakpoint again, then it would pause again, but right now it's not. Okay. Now, I just paused the game, though. So I did hit that pause button. How did I pause the game? This is kind of a cool thing. Now, one of the things you can do is you can pause the physics engine. Right. Now, you'll notice that my mouse is still moving. The basket is still moving. And I certainly can still hit the pause button. Right. And the game ended. So how is that occurring? How do I pause the physics engine? Now, this guy is moving back and forth. If I look at the tree is moving according to tree script, and the tree script is moving back and forth according to transform, translate, according to time delta time. Now, if time is not passing, then time delta time is not going to be incrementing, right? So that's going to pause that right there. So no translation is going to be occurring. So even though this is not physics-based, since I'm using delta time, that's also being affected, right? So let's see. Let's find that code where that pause is. Now, that pause button there, if I click on that, let's go to our canvas. Oh, I should go to the scene. I shouldn't go to the game window there. So go to the canvas, and here's our pause text here. And there's the pause toggle. And when pause toggle is, when its value changes, on value changed, it calls GameManager.pausePlay. So let's go into Game Manager, which is on our manager here, Game Manager. And let's look for pause play. Here it is. Okay, there's pause play. So the one thing it does, don't pay attention to this too much. This is my subloaded. That would go away. That just gets rid of it. But it says, okay, first it checks to see if pause, which is the value that's being passed, right? If that's true, meaning it's checked. If it is checked, we turn off time by changing time.timescale to 0. So that stops the physics engine, stops the passage of time. Otherwise, if we passed in 0 for some reason, because the value changed to 0, we would set time scale to 1, meaning pass time normally. Okay. Can you set this to things other than 0 and 1? Yes. And that means you can use time scale to speed up and slow down your game. You can't make it go backwards. You can't go back in time. I don't think. Never tried that, but I don't think you can. And the other thing I do is I say, well, okay, in here, remember I have that big red paused text down here, paused text. I set that active according to whether or not we are paused, right? So that's how I get this paused thing to show up, right? So in my game, I press play. I can pause gameplay. Oh, guess what? Guess where it's sitting right now? It's sitting right here again because I'm still debugging. I should go up here. I left click on that, debug this breakpoint to get rid of it. So now I can then just say continue, and the game will play. Oh, and I'll pause. I pause the game. Make that big again. And I can continue the game. All right. So those were some bonus things in there, learning about loading scenes and learning about time scale, which allows us to do like pausing things. But let's go back to the general stuff in the game. So if I hit play, your game should be doing, you don't need that fanciness, but you catch apples. It makes a sound when it hits the basket. There is a different squashing sound if it hits the ground. Ready? Listen. I don't know if you can hear it. It's like a crunching apple sound if it hits the ground there. And if it hits the ground, I lose a basket, and all of the apples that are in the air get destroyed. Ooh, I got a high score. I beat the high score. Oh, no, 25. I get 25 apples. I get an additional an additional basket. That's also an option. I encourage cool options like that, though. So it gets a da-da-da-da sound, and I gain back a basket. Here comes 50. Let's see. Yep. All right. So let's see how crazy I can get here. Nobody's asked any questions. I got 4. That's right. I think I limited. You can get up to 5. Whoops. Yikes. Up to 4. All right. So the important things that are happening when I miss the basket. Wow, that score, high score, crazy. When I miss the basket with the apple, all of the apples that are on the screen get destroyed. That's a requirement. So let's see. Someone posted time.timescale equals 0. Oh, someone. Okay. If you want to type questions, that's good too. Or direct message me if you have a specific question about your specific project. But all right. So gameplay wise, this guy is moving back and forth when it hits the edge of the screen, and also randomly. And he also moves faster and faster, so his speed is changing, and he's changing direction more often. Even without hitting the sides of the screen, he changes direction more often. He also drops apples faster and faster as the game goes on. Okay. So those are the main play mechanics with regards to that thing's behavior. All right. I have a stack of baskets every time I lose a basket. Now let's see. I think I made this a feature. Let's see if this feature still works. I made this a feature of one version, but let's give this a try. You'll notice that there is a player in the scene, but there are no baskets. So let's see. If you want to get fancy with me, here's how we can do this. All right. Say I were to come over here and put this basket. Let's see. Oh, I'm going to go to the scene over here. I go to main camera. All right. The player is at 0. I'm going to grab this basket, put that in the scene, put this basket in the scene, and put this basket in the scene, and hit play. Oh, this isn't that version. Darn. Okay. There's at least another version of the game out there where it automatically will detect whether or not I have any placed baskets in the scene. And it will add those as children of the player automatically. So if someone wanted to design their own version of that, they could, but I must have disabled that. Oh, well. How would I have done that? So you'll notice there they are in the scene. And we're just going to push them down to the bottom here. And this fancy code was in the player. And what I used to do is I would, or some version of this, I would get any objects in the scene that were tagged basket, right? If they were tagged basket, and I would automatically say, okay, don't create a new one, but instead put those baskets into this scene. Okay. So how would I do that? All right. So this is a list of baskets. Now, if I wanted to, I could say game object baskets. So let's see, did I get that backwards again? Oh, that should be capital. And there we go. Baskets is declared but never used. Okay. So this is saying, okay, baskets should refer to an array of baskets. So watch this. This is just an added bonus. We're going to say baskets, not basklets, baskets equals game object dot find no, get. Where was it? Where was it? Let me think for a second here. Get game objects by tag is what I want to do here. And I usually never use game objects by tag. Is it find by tag? Find object of, there we go. Find object of type, no. Find all right, I'm just drawing a blank here. Find object of type of game object. No, because that'll find all game objects. I just want to find the ones that are tagged. And it's just, I'm just drawing a blank on the syntax here. It is literally get, game object by tag. It's like game objects with tag. Unity game objects with tag. Okay. Why didn't it? There we go. This is what it should have said. It should have said find it's because I find game objects with tag. Is it game object? That's probably what, okay. And maybe a capital F there would help. There we go. I don't know why it wasn't finding that. Find game objects with tag. So this is going to find all the game objects tagged basket and put it in baskets here. All right. Now, watch this. Here, I'm going to have somebody had a message held with for review. Did someone swear? Okay. Find tag. That would have, but I wanted to find objects. I wanted to find all of them. Okay. So if you have other questions, this isn't required for the project, but it's a cool thing. So here's what I did. It's like, okay, assume we want to get 3 baskets at least, right? So normally, I'm going to do this. I'm going to say, this is how I would instantiate I'm going to say here, just game object basket to add. Okay. And right. So I'm just kind of clearing this up a little here. I have game object, that should be a capital. Game object basket to add. And we'll put a semicolon there just to make that sure. Okay, so now this will just work. It'll say game object basket to add, and I just kind of said basket to add instantiate like normal. Okay. But what I'm going to do here is I'm going to say, okay, if baskets I now let's see. Now first I want to say, okay, baskets. I need to say baskets what? Baskets dot length is greater than or equal to I. All right, so I'm going to say if there are baskets that I've placed here, and there are more of them than currently I, so I want to say basket to add equals baskets I. And then the last thing I want to also add is say basket to add dot parent let's see, I'm going to remember this one again. Set parent. Transform dot set parent. That's a function. And I can set that to this. What transform is that is the parent of this guy, right? So what I'm going to do is going to say this basket gets its parent set to this object that I'm, right? The transform attached to this game object. Okay. So let's see if that'll work. So it said, okay, if I have baskets and there are at least, you know, enough to grab one of these, right? I'm going to add that. I'm going to make its parent the player, and I'm going to add it to that list. Frightening, if that works. So I put 3 in the scene. This is, I hit play. Oh, look at that. Whoa. So I can catch with either of them now. I lost one because I just wasn't. So let's pause. And if we look over here, you'll see now those baskets that I had, basket 1, basket 2, they got placed in here. Right? Now, the weird thing that I could also do, you see that I put 3 of them in the scene. Now, because of the way I structured my code down there, if I were to take one of these out, oh, index was outside the bounds of an array. Not cool. All right, so baskets array greater than, that should have been greater than, not equal to. Right. We had to fix that. And let's start over again. Did I fix it? Or did I? Yep. So you see I had my bonus one that was in the correct spot there. All right. So what this is showing, what the real purpose of this, now you're all scratching your heads going, why the heck did he do that? Okay. If, for example, you want to allow, because now I could let my level designer place objects in the scene and have the objects put themselves into the hierarchy in the correct places that they need to be in order to be controlled by. That's the cool thing about this particular demonstration, I like to think. so that, if I delete these baskets from the scene here, the game will put the baskets in the default place, right? But if I do place baskets in the scene, and it will allow for, 3 of them, right? And I'd probably have to get fancier if I wanted to really do anything too crazy. Put one over here. This actually makes the game even more challenging. So now it'll put them like that. So now, rather than have to algorithmically generate where exactly they are, I can allow someone to design their own level to this game, right? That's the key thing, because they're added to this basket list, and because they are set so that their parent is the player, they will move with the player. All of their stuff will be treated just as if they were instantiated, right? I could do something even crazier. I could watch this, all right? I get fancy. I'll take one of these and I will rotate it. And I'll rotate that one. Right. So yeah, it's a way to make sure. Now, if I wanted to, I could have also just made these children of the player. I could have faked this out, and then just, if I put them in here, they wouldn't be instantiated. They would already be children of the player object. So there's always lots of different ways to do the same thing. But you should be aware. You should always be aware of at least 2 ways to do the same thing, just so you have options. If one doesn't work, you can always try the other one. Right. So I'm just getting fancy there. My text fields here, I have one for high score, one for the regular score. So if I double click on Canvas, we scroll in here, click on one, we'll see we have score text and high score. There's score text, there's high score. In here, most of the sounds, what I did is I put the sounds, I think they're on the player, right? So the squish sound, the swish sound, and the success sound. The success sound is da-da-da-da, I think. Is that the, let's see. Sounds. Yep, in case you didn't hear, that's a trumpet blasting. Da-da-da-da. Squish sound is like a apple crunching. The swish is the apple going into the basket. The bubble sound, I have a bubble sound, which is on the prefab of the apple. So anytime an apple is instantiated, we get that apple boop sound. So and then there's the que sera sera sound, which is only used in the loading scene, right? I just have that there as some, cool ambient kind of fun intro game loading sound. All right. So this was the added bonus. What am I forgetting? In the game requirements, the tree moves back and forth. The baskets move back and forth. The apples are dropped according to physics. So if we look at the prefabs here, trying to anticipate problems. The apple prefabs, they have their bubble sound on them, and it plays on awake. That's what means I don't have to explicitly play the sound. It just plays on awake. So the moment an apple exists, it plays the bubble sound. It has a rigid body on it. so that it will drop the moment it is instantiated, is a dynamic rigid body. It has a circle collider on it so that when it falls, it will potentially hit the basket, causing a collision with the basket. The Apple script function, and yeah, this was created on a Macintosh. That's why it does that. The Apple script function, let's see. There will be multiple instances of the Apple prefab. Use statics initialized by the singleton pattern for efficiency. So I have some things that I don't want to calculate all the time, right? I don't want to recalculate the player object. I don't want to recalculate the corners of the world for some reason, right? So I use that. You don't really have to do this in a singleton pattern, but if you want to do this, you can, right? The main things that the Apple has going for it is that the Apple needs to know when it falls off the bottom of the screen. So if the Apple falls off the bottom of the screen, it knows to destroy all of the apples in the list and tell the player that we lost a life. So this is all the apples being kept in the list here, right? They're added to the list every time the tree drops them, right? The tree comes along, the tree says, okay, throw it, which is throwing an apple, right? I have two versions of throw apple. Oh, that's when it's going to throw the apple, and then it actually throws the apple, right? So throw apple decides the interval that it's dropping at and how fast. Oh, it actually even speeds up the gravity of the apple's dropping. It's kind of evil thing. It scales up the gravity of the apple. So it decides to throw an apple, and every time it throws an apple, it also, I think it potentially changes direction. That's when I have it potentially changing direction in this particular version. All right. So throwing an apple means instantiating it, and let's see. So who adds it to the list? Let's see, Apple script. All right, we have the static Apple list. Oh, all right. So here's how the apples get added to the list in my game. Now you would have the option. You always have a couple of different options. You could say AppleList.add every time the tree threw an apple. But in my case, what I do is when the apple comes into existence, it calls this AppleList.add right here. All right, that adds this apple to the list. So that when it comes time to destroy all the apples, it can say for each apple in AppleList, destroy the apples and clear the list and tell the player that it lost a life. All right. Now, if the apple collided with something, it probably means it collided with the basket. So I check just in case. I could have it enforce this through the physics 2D collision matrix if I wanted to, but I also compare it to see, okay, did the apple fall and hit a basket? If so, remove the apple from the list and tell the player script that I hit your basket, and then go ahead and destroy the apple. So this part here, hit basket, is what's going over in player script. Player script hit basket right here. So if an apple hit the basket, play the swish sound and potentially, let's see, potentially give us a bonus life if we've hit 25 apples and we have fewer than 4 already. We do that. Where do we add to the score? Let's see. That's a good question. So player script. Where does Game Manager have the score? Yeah, in this version, I think Game Manager has the score. Increment score. So who is calling increment score? Well, if the Apple script isn't doing it, I don't see increment score here. Then what must be happening, I assume, is that is there a basket script? No. I must have missed it. Maybe it is an Apple script. Apple script says hit basket. We didn't increment score here. Let's look in player script. Oh, wait, let's see. Could you actually go in depth on the whole AppleList thing again? I know you went over it, but I was a bit lost on how I'm. Okay, we'll do that again. As soon as I find my increment score here, I just want to make sure I'm. Oh, there it is. It's right. It's kind of hidden. That one's a little bit hidden. That was kind of tough to find. I forgot I put it there. So this game manager.increment score incremented the score and returned the new value. So that's what this was doing here. So every time it hits a basket, it incremented the score and then checks all this other stuff. So it's that's a little bit hidden. All right. So the basket list, or the basket list, the Apple list. You want to see the Apple list again. All right. So the idea is that every time an apple is created, we want to put the apple in the list. Right? Fair enough. So we know that when an apple starts out, right, when any object starts out, it's going to have its start function called. All right. So that's a good spot to add it to the list. Now, I need to have a spot, and I'm going to change this a little bit here. I'm going to put this in, I'm going to call void awake. Awake is actually going to happen before start is. And I'm going to take this bit of code here. Nope, not that part. Oh, I don't need to do that. Sorry, scratch that. Get rid of that. I'm not going to add an awake. I'm not going to change anything. Don't change any code. So Apple script. Pause again. The Apple script needs to put an apple in a script. But the question is, the Apple script needs to put an apple in a list. The question is, where is that list to begin with? Here is the list. Here's the list I'm going to put it in. Now, I've determined that even though there's lots of apples, there should only ever be one apple list, right? I'm only maintaining one list for all of the apples. So I declare it to be a static list of game objects called AppleList, and I initialize it here, right? So here's the magic. Static list of game objects called AppleList equals new and instantiate a new list. It's static so that only one of these will be created, right? That's the important part. Only one AppleList will be created for everybody based on this class, right? So anyone who has this component, they can all refer to the AppleList, and that's the same AppleList for all of them, right? Now, later on, start, this is not a static function. Start is called for every apple that is instantiated. Right? Don't worry about this upper part here. This is, unless it's slightly more advanced, but with regards to the apple itself, the important part is during its start routine. During its start routine here, it is calling AppleList.add and passing that list its game object. So it adds itself, right? It gets on the train, puts itself in the list using AppleList.add and says game object. Game object is the current game object that we're attached to. So this adds it to the list. So every time I add an apple, it adds itself to the list. Later on, when an apple hits the ground, meaning its position is lower than the Y of the edge of the screen, that's what's happening here. I've calculated this. Maybe you have this set to a magic number. Just the bottom of the screen is probably like -5, right? So if this guy's position is less than -5, I know I need to destroy all the apples in the list and clear out the list. That's what this is doing. It says for each game object apple in AppleList, destroy all the apples, clear out the list, and tell the player that you've lost a life. Okay? So that's what's happening here. Right? Destroys each of the apples, clears the list. Now, the one thing you'll notice here is that it is not removing itself from the list. It's not actually removing anybody from the list. It's just using the list to destroy all the apples and then clears the list in one fell swoop. Right? So it just totally clears the list here. There's a reason for that, because if you are working with a list like up here, where I'm saying for each apple in AppleList, if I were to try to remove this apple from the AppleList inside this loop, that would not be good. You should not be manipulating a list inside a for each that uses that list. So that's something to watch out for here. So the other piece that you need to know is that when an apple collides with a basket, it is going to remove itself from the list, right? Because only this one apple needs to get removed from the list, the one that collided with the basket. So that's why AppleList.remove happens here. It removes itself from the list. And then later on, it destroys its game object. So here it is destroying itself. So that's the important parts of the list. The apple, if it collides with a basket, needs to remove itself from the list. The apple, when it comes into existence, needs to add itself to the list. And when an apple drops off the bottom of the screen, it needs to destroy all the apples in the list and clear the list. And the list itself is initiated or initialized, declared as a static, so that there's just one list for all of the apple components, all the apples that are of this class, the instantiated apples. Whew. What counts as game object apple? Are you referring to this here? In a for each loop, you have to declare an instance of the object, right? An instance of the object that's going to act as the iterator for the loop. So it's sort of like saying for int I equals 0, I equals whatever, right? So you have an iterator, right? So this stands in as the iterator for the for each in the AppleList. So Apple will go through and become one at a time each apple in that list, and it will perform the body of the loop for each apple that exists that's what it says, for each apple in the list. And you just use the apple variable as the iterator to refer to the one that you're currently working with. Sure. Okay. Yeah. This could be this could be glob in, right. These are just game objects, right? The list, we call it an AppleList because it happens to be that all of those game objects happen to be apples, but they're really just game objects. They could really be anything, and they would still be destroyed and removed from the list, right? You don't here, as long as it's a game object in that list, it doesn't care what's on it. It doesn't care what components it has, doesn't care anything. It just knows that it is a list of game objects, and game objects can be destroyed. The only thing you'd run into an issue here is if you said, okay, glob dot get component AppleScript, and tried to do something here. You know, what could we refer to? Corner. Well, I think maybe we could refer to corner. Yeah. So if we were to do something like this, that would be an assumption on our part that this game object had an AppleScript component on it, which it, as far as Unity goes, it'll try to run that code. But yeah, we're not iterating over anything that necessarily, it's just whatever's in that list, and we put it in the list right here, right? So you could literally have a list handler function that was just or a list handler component, a class that you added to any number of different prefabs, that the only thing its job were to do would be, okay, if I exist on an object, during start, add this object to the list to be destroyed. And then if I cross the bottom of the screen, I'm going to destroy everybody in that list. And I don't care what they are. I don't care what components they have, as long as they have this one component on them. Does that, yeah, right. No problem. It's a good, as you get into the multiple things, you remember, that it does become a little bit tricky. And it is kind of one of the powerful things about components like this, is that you don't have to have all the functionality in one component, right? You don't, this way, it doesn't matter if it's apples or rocks or pitchforks or, bird poop, whatever it is, as long as that particular, a dropped item has that behavior, you can create that dropped item class, right? And then just include that component on anything that's potentially dropped that needs to act in that way, right? That's the cool thing about, being quote unquote object oriented in this way, right? Because we can install an object oriented script kind of capability to something, and then it's just, okay, whatever it is, everything else is still independent of that, but this one thing can be shared across them. So if it's like collectible, if it's destructible, in future games, like in the shoot 'em up and so on, I create a script that can take damage, right? So no matter what it is, doesn't matter if it's a boss or whatever, it just knows that, okay, this is the damageable script. And then it'll have a behavior that, once it takes a certain amount of damage, it destroys itself. And you can even do things to say, oh, it has a blast radius. And then okay, if anything else is within its blast radius, anything that else, whatever you want it to do, sort of thing. You can, really reuse those behaviors by, keeping, you want to keep your scripts fairly tight, fairly compact. If you can reuse them, the smaller you make the functionality, or the more concise you make them, the more reusable they are potentially. So well, tag is just the tag system is really just a shortcut, and some, it's kind of convenient to have a thing that you can refer to as a generic kind of tag thing, kind of already ready, but it's independent, like, because you could, once you know that this object has this script on it, I could refer to any local variable or any instance variable or class variable and work with those, rather than work with a tag. If I wanted to, I could be much more, the tag system is really about, like, finding objects with that tag, and it'll go through, and if you want to do that, it's there as a convenience. It helps you to, you can sort of, preload things in here, like this for each. We used a list to keep track of things. You could say for each game object glob, or for, if you'd created an array of things that were tagged with that. So yeah, the tags are just sort of a shortcut, a convenience to find things of a common tag that isn't necessarily a common type, right? So yeah, tags are sort of, tags exist at the object level, not at the component level. So they're kind of a convenience for that reason. So if you need some way to find, like, all of these game objects, I don't know what's in them, I don't know what components are on them, and I didn't bother to keep track of them in a list, you can then, use a tag also to get it. If you have the text, if you have the prototyping in Unity, they show the destruction of all the apples by, rather than using a list, they just say, oh, for each game, or they get an array of game objects that happen to be tagged apple, right? And when you say that for, after you get that list of those tags, then you could just run through that local array and delete them if you wanted to. Tags are tempted to, they're tempting to use, but I think most people recommend that you try to stay away from them for a lot of reasons, just for reasons of efficiency and so on. It's better to kind of design explicitly to manage things, as opposed to, using that generic tagging mechanism. It just tends to be a little bit slow when you run into larger projects. All right. So I've probably added enough complexity and confusion. Let's see. Someone wanted to ask, let's see. If an apple is caught, are you removing it from the list? If an apple, yes. The apple caught is right here, this collision, right? This collision is the apple prefab and something else collide, right? If I collide with a basket, it means I'm caught. Then here's where the removal happens, right? That this game object that I'm currently on could be an apple, could be a pitchfork, could be whatever. If it was caught, remove it from the list, right? Probably not necessarily the only way to use the list is to destroy everything, but would it be... the only way to use the list is to destroy everything. Well, no, you definitely want to do this, because you don't, if you've destroyed, if you destroy the apple as a result of catching it, it no longer exists. So you definitely want to take care of it from the list. Otherwise, you're going to wind up with zombie, things in the list here. right? If you're about to destroy something, if you're going to call destroy, best practice, make sure it's removed from the list before you destroy it. Otherwise, you potentially leave sort of zombie, open, undefined list elements up here, right? You don't want to do that. So if you're going to destroy something and it's on a list, best practice, make sure to remove it from the list before you destroy it. So hopefully that answers the question from Dankstar. Okay, so let me, yes. Okay, so I'll repeat it for the YouTube stream. And the question was, in terms of a strategy for managing this, how does it? What's my strategy for playing the sound so it doesn't get destroyed? Because if you do try to play the sound on the Apple and then you destroy the Apple, it won't play the sound, right? So you have this weird thing. If I, in here in update, here's where I destroy all the apples, so that if I destroy an apple and it's in charge of playing the sound, then it will be no good. And the same thing, if you put it on the basket, that's no good, because the basket also is going to disappear as a result of that, potentially, or one of them. So what I did is I said, well, okay, it's actually the player, right? So the player always exists. No matter how many baskets there are, no matter how many apples there are, the player always exists, right? So certain sounds, the player is in charge of playing. So here's the squish sound, right? So when you tell the player to lose a basket, right, the player itself, you'll notice in that one, it also there we go. Where am I? In here, the Apple doesn't tell it to destroy a basket here. It says, okay, call player script lost life, right? And in player script in lost life, it says, go ahead and play the splat sound, because the player will always exist. The player's only going to lose the life, right? So it knows, go ahead and play that sound. Now, here's one hidden feature that I've never seen explained particularly well in Unity. So you'll notice here, game object get components, and you can get all of the components of that type, right? So I use this to get all of my audio components. So the player has 1, 2, 3 audio components, audio sources here. The first one is the squish sound. So that would be element 0. The second one is the swish sound. So we've got the squish, the swish, and the success sound, right? So in the player's script, if I reference 0, that is the squish sound. If I reference 2, that is the success sound. And if I reference 1, where am I doing that? 1 was which sound? That was the catch sound. Okay, so that would be in increment score, right? Lost life. Hit basket, lost life. Well, I'm going to guess if I come over here to Game Manager and I look in increment score and show scores. That's not where I did it. It should be in the player. Let's just look for, there it is. Hit a basket. There's the swish sound. So every time any object hits the basket, you play that swish sound, which is sound 1, right? Because this is an array here. Get components returns an array. So the key is S, right? That means return an array. See, it's audio source array. So that's how I can get 1 from that one, and 0 from this one, and 2 was the which was in the, yeah, right there. So they're both in there. That's right. Hit basket. This is gain 1 point, and here is the play when you get an extra life there, that sort of thing. So yeah, your sounds that play, especially if they're playing in response to something else being destroyed, you have to make sure they're not on the object that's being destroyed. Playing the come to life sound that the apples make when they're instantiated, that's okay for them to be on there and part of their play on awake, because they'll exist at least long enough to play their boink sound. So that one works out. Good, very good question. Very good question. It's always tricky to anticipate every. That makes it's the fun of game development, fun of game engines changing all the time. Yeah, it becomes tricky in general when you're talking about, when things and sooner or later, especially probably as you get into your shoot 'em up game, when you have things that are destroying, objects that are destroying one another, and you say, well, okay, should the code be in the thing that's doing the destroying, or on the thing that's being destroyed, or on somebody else entirely? So you sort of have to think like, well, sometimes, it depends if and you can do things like, if you destroy the object, maybe you destroy the object in such a way that it takes a second for it to die, in which case it gets to play out its sound. Or in the case of, like I did it once for the asteroid style shoot 'em up game, where if you shot a bullet or shot a missile at an asteroid, the asteroid, you'd think the explosion sound happens with the asteroid or the bullet, but actually the action of the bullet hitting the asteroid instantiates a explosion, which is an entirely different object, and that, as long as that exists, it makes the explosion sound, right? And then when it is done playing its sound, then it destroys itself, right? So you have all these different circumstances where you have to sort of just think to yourself, well, okay, what is the life cycle of the objects that I am working with, and is it really the object itself that's making the sound? Is it the interaction? Does the effect live on outside of both of them? Because you always have that decision to make, even the apple hitting the basket. Okay, at that point, who gets to increment the score? You have to decide, and then just kind of go from there. But then ultimately, one of them, they should be calling an API to the scorekeeper, something else that exists beyond the two of those, for example. Whew. Good questions. Good questions. Okay, I'm going to, at this point, let everyone have the rest of the time, a good half an hour or so, as bonus time, work on the projects, wrap things up. I'm going to go ahead and put the LMS submission point up. I'm going to stay tuned in, and I will type answers unless anyone has any other questions that they want to see answered in the stream at this point. Any last minute questions? All right, good. We're going to sign off and weird. Yeah, it's been okay for me. So I don't know. Maybe it just likes me because I pay it money or something like that. I'm my actual member. That's what you got to do. You got to fork over the big bucks. So that's why my streams look so sweet.
Sometimes. All right, everybody, enjoy. Look forward to seeing your projects by midnight tomorrow or after midnight tomorrow. Okay, take care. Good luck.